Imagine looking up at the night sky and seeing a star that shouldn't be there, a flickering visitor that defies the eternal maps of the heavens. For centuries, we believed the stars were fixed and unchanging, yet history is whispered with tales of new stars that appear and vanish like ghosts. While we often wish upon falling stars that are merely pebbles burning in our atmosphere, there is a true falling star out there in the deep. This is the story of Mira, the Wonderful, a celestial giant that challenged our understanding of how the universe breathes and how stars die. Our journey begins in the year 1596, when a pastor and astronomer named David Fabricius noticed something strange while tracking the planet Mercury. In the constellation of Cetus, the Whale, he spotted a star shining at the 3rd magnitude, a star that was absent from every existing map. At first, Fabricius assumed it was a simple mistake or a temporary fluke, but as he watched, the star's brilliance began to swell with intent. By the end of August, it had become the brightest jewel in its constellation, outshining its neighbors before beginning a slow, mysterious retreat into darkness. By October, the star had vanished completely, leaving Fabricius to believe he had witnessed the birth and death of a singular, short-lived cosmic event. However, the universe rarely reveals its secrets so easily, and 13 years later, the ghost returned to the exact same spot, in the Velvet Void. Other astronomers like Johann Bayer and Jan Hevelius began to track this flickering beacon, realizing that some stars do not simply burn, they pulse. Hevelius gave it the name Mira, Latin for amazing, marking the discovery of a new class of celestial objects known as long-period variable stars. To understand Mira, we must first understand the scale of a red giant, a star that has exhausted its hydrogen and begun to swell. Mira is a behemoth, roughly 700 times the diameter of our Sun, a size so vast it would swallow the orbit of Mars if placed here. It is a star in its twilight years, caught in a cycle of instability where its internal temperature and outer atmosphere are in constant, violent flux. Unlike the steady clockwork of our Sun, Mira's brightness can increase by over 1,000 times in a cycle lasting roughly 332 days. During its peak, it is a brilliant lighthouse in the dark, but during its minimum, it fades until it is invisible to the naked human eye. Scientists believe this pulsation is caused by changes in transparency, where cooling gases form molecular clouds that trap light before heating up and dispersing. It is as if the star is struggling to breathe, expanding and contracting in a rhythmic dance that signals its eventual transformation into something else. But the heartbeat of Mira is only the beginning of its strangeness, for this star is not traveling through the galaxy alone or quietly. For a long time, we thought Mira was a lonely giant, but in 1919, astronomers noticed a strange overlapping signature in its light. It was a second spectrum, one belonging to a much smaller, incredibly hot object hiding in the giant's blinding glare. 4 years later, a tiny companion was finally seen, a white dwarf now known as Mira B, orbiting its massive partner. This little star is a cosmic scavenger, a dense remnant of a dead sun that survives by feeding off the giant's outer layers. Every 400 years, Mira B completes a single orbit, meaning it has only made one full circle since Fabricius first looked up. The distance between them is vast, about 70 times the distance from the Earth to the Sun, yet they are locked in a deadly embrace. As the red giant Mira A pulsates and sheds its skin, the white dwarf's gravity acts like a vacuum, pulling in stray gas. This gas forms an accretion disk around the dwarf, a swirling whirlpool of matter that heats up and glows with erratic intensity. Because the giant doesn't exhale its matter evenly, the dwarf's appetite is sated in bursts, causing its own brightness to flicker. It is a chaotic celestial partnership where the death throes of one star provide a flickering lifeline for the ghost of another. But even this binary dance was not the most shocking discovery. That revelation came from a satellite called Galax in 2003. While surveying the sky in ultraviolet light, Galax revealed something that had been invisible to human eyes for all of history. Behind Mira, stretching through the interstellar void, was a colossal tail of glowing gas trailing like the wake of a ship. This tail is not just a few million miles long, it spans an incredible 13 light-years across the fabric of the Milky Way. To put that in perspective, the distance to our nearest neighboring star, Proxima Centauri, is only about 4 light-years. Mira's tail is 3 times longer than the distance between us and our closest stellar neighbor, a trail of discarded history. Most stars in our galaxy drift slowly and predictably, moving in harmony with the surrounding clouds of interstellar gas. Mira, however, is a rebel, screaming through the galactic medium at a staggering speed of 130 kilometers every single second. It is moving so fast that it has outpaced the gas it sheds, leaving its own atmosphere behind in the cold, dark silence. Every 10 years, the star loses a mass equivalent to the entire Earth, fueling this gargantuan trail of cosmic debris. To visualize this cosmic trail, imagine a boat cutting through a still lake, creating a sharp bow wave at its front. In front of Mira, a massive shockwave of compressed gas forms as the star rams into the interstellar medium. This bow shock is the point of impact where the star's ejected matter meets the resistance of the galactic clouds. The result is a luminous glow that scientists can study to understand the chemical composition of the star's history. Because Mira has been shedding this material for over 30,000 years, the tail acts like a chronological record of its life. By analyzing different sections of the tail, researchers can see how the star's temperature and pulsation have changed over millennia. It is a rare opportunity to see the ghosts of a star's past lives laid out in a single, magnificent line. But why is Mira moving so fast, while most other stars in the neighborhood drift along like lazy river rafts? Most stars belong to the galactic disk, moving in circular orbits, but Mira is likely a visitor from the galactic halo. These high-velocity stars have erratic orbits that dive through the disk at steep angles, moving like cosmic outsiders. Mira is essentially a runaway giant, a traveler passing through our part of the galaxy at speeds that defy local norms. This high-speed travel combined with its shedding atmosphere is what creates the shooting star effect on a stellar scale. While a typical shooting star is a brief spark in our sky, Mira is a permanent 1-3 light-year-long streak across the universe. This discovery has changed how we look at empty space, proving that the vacuum between stars is filled with hidden structures. We now know that Mira is not a unique freak of nature, but a representative of a much larger family of variables. To date, we have discovered more than 46,000 variable stars in the Milky Way, each with its own rhythm and story. Some pulse with the precision of a Swiss watch, while others, like Mira, are temperamental and fluctuate with wild irregularity. These stars are the engines of cosmic enrichment, blowing heavy elements into space to be recycled into new suns and planets. Without the violent shedding of giants like Mira, the universe would lack the complex chemistry required for life to even begin. Every carbon atom in your body may have once been part of a stellar atmosphere cast off into the dark. The story of Mira reminds us that the universe is not a static museum, but a living, breathing, and often violent laboratory. What we once saw as a simple point of light in the night sky is actually a complex system of two stars locked in a feeding cycle. It is a giant that is literally coming apart at the seams, leaving a trail of its own history as it screams through the galaxy. This amazing star forced us to reconsider our place in a universe where even the suns themselves are transient and changing. We used to fear the stars that moved or vanished, seeing them as omens of chaos or signs of divine displeasure. Today, we see them as opportunities to learn about the physics of the extreme, the limits of gravity, heat, and time. Mira A will eventually shed its entire outer shell, leaving behind a glowing planetary nebula with a white dwarf at its heart. Its companion, Mira B, will continue to feast until the supply runs dry, perhaps evolving into a new kind of stellar remnant. The 1-3 light-year tail will eventually disperse into the interstellar medium, seeding the galaxy with the ingredients for future worlds. This is the cycle of cosmic reincarnation. A star must die and scatter its remains so that new life can eventually emerge elsewhere. We are lucky to live in a brief window of time where we can witness this specific, glorious moment in Mira's long journey. It serves as a reminder that even the most fixed things in our lives are subject to the grand, sweeping changes of the cosmos. We look up at the night sky and see a snapshot, a frozen frame in a movie that has been playing for billions of years. But telescopes like Galax allow us to press play, revealing the motion, the trails, and the hidden connections between the lights. Perhaps there are other wonders hiding in the dark, amazing things that we simply haven't built the right eyes to see yet. As we continue to map the variable stars of our galaxy, we find that the universe is far more rhythmic than we ever imagined. Every pulse, every flare, and every long trailing tail is a note in a vast, silent symphony that we are only just beginning to hear. So the next time you see a shooting star, remember the giant Mira, the true falling star that has been falling for 30,000 years. It reminds us that being small in a vast universe isn't a reason for fear, but a reason for profound, unending curiosity. In a universe this big and this strange, there is always something wonderful waiting just beyond the reach of our current maps.